This video will cover how to fit linear regression models in R. The basic idea of the linear regression model is that you have an interval ratio dependent variable, and then you have one or more independent variables that can really be at any level of measurement. The example data that I'll be using to get through this tutorial is the 2016 wave of the General Social Survey. So the first thing that I'll do is just load that in, and that's it. So I've created a data object called GSS, which I'll be using to fit my model. So the basic command that you need to fit linear regression models is LM for linear model. From there, you open up parentheses, and then you type your dependent variable given, so a tilde, and then x1 plus x2, and so on. And if you have a data frame, then you would just type data, in my case, GSS. And that's really the kind of core command, although you'll see that we need to do just a little bit more with it. So the first model that we're going to fit is going to look at the respondent's occupational prestige, which is G10, given their age, and father's prestige, which is Pres10. So if I just fit that model, you'll see that it probably isn't returning exactly what you're expecting. So you do have the point estimates. So this is your intercept. That's your partial slope for age. That's your partial slope for father's prestige. But you're probably looking for a lot more information, like your f-test, the statistical significance maybe of the individual pieces of the model, your r-squared, and things like that. So the lm command returns a pretty bare bones set of results for you. And so what you'll typically want to do is just create a model object that you'll save. So I'm going to just call mine M1. And now you'll see if I run this and create this object, it pops up in my global environment right there called M1. And from there, you can run summary on your model object, very similar to what we actually did for the analysis of variance video. And if you run that, now you'll see that you get actually the results that you want. So starting at the top, it gives you the distribution of your error term. It gives you your point estimates, as we saw above. So that's your intercept is 32 prestige points. Age is 0.07 prestige points. Father's prestige is 0.20583 prestige points. You get your standard errors in the next column. The t-statistics associated with each individual piece of the model, the p-values associated with those. R also includes the stars to flag statistical significance. And then if you look down at the bottom, you'll see that you get your f-test. So here we had an f statistic of 50.27 on 2 degrees of freedom between, 2159 degrees of freedom within. And that gives us a statistically significant model at all the standard levels of confidence. And so really that's everything that you need. And R-square right there. So it's around 4.5% of the variance in prestige is explained by age and father's prestige. That's all that you need to really get these models, but it's worth noting here that I've intentionally only included interval ratio variables so far. So then the question becomes, well, what happens if you give R a categorical variable? Because as you might know, those sorts of variables need to be coded in a very particular way in order for them to be entered into a regression equation. Well, it ends up actually that if R is given a variable that's either a factor or character, it will create all of those indicator variables for you. Some people call these dummy variables. And you can see this pretty easily by just adding in a new independent variable. So here I'll do plus sex, which is just a dichotomous variable. So if you look, GSS $sex is just men and women. And so if I add that in, it will just add that variable nicely coded as an indicator variable for me, just like that. And so you can see from this line right there that the reference category is male and that female is coded as the 1 in the 0-1 coding system that R will create for us. In this case, it's actually not statistically significant. So according to this model, at least, occupational prestige isn't really a function so much of sex after controlling for age and father's prestige. The other thing that's worth noting is that even if you have more complex categorical variables, R will still take care of that for you. So if we wanted to check degree, which is just educational attainment by degree, you can see that we have all of these different categories. That's fine. You can just add it as is, and R will take the lowest level as the reference category. So in other words, here it will be the people that have less than high school. So I'll just add that term to my model, run it again, and you can see that we have now partial slopes for high school, junior college, bachelor's, and graduate degree. And you can see that, as you might expect, as we become more educated, we get a boost in our occupational prestige relative to those that have less than high school in their educational attainment. And so that's really the basics of how to fit these models. There's a lot more that you can do here, such as adding interaction terms, plotting some of the results, and all that sort of stuff. That's really kind of beyond the scope of this video, which is really just the basics of how to fit these. But if you look into the help file for LM, you'll see that there's a much broader discussion of what you can do with these.